you take a look of this linear system, you would see that of course it is a differential equation term, okay, and we have two uh, dependent uh, two dependent variable and one independent variable. Two dependent variable are x1 and x2, and one independent variable are t, right? Now, this equation is a homogeneous equation, right? Because you don't have any function of t. If you have function of t, then it's a non-homogeneous equation, right? This is a real homogeneous equation. So the way to find the answer of this linear system is just that you've got to assume the answer, okay, x1, we can put it in metric form, x1, x2 is equal to k1, k2, okay. So that means, this one means x1 is equal to k1 times exponential of lambda 2, and x2 is equal to k2 times exponential of lambda t. And then, like I said, the way that we are going to do is just we plug x1 and x2 into our linear system. Okay, the first derivative of x1 by t is equal to k1 lambda exponential of lambda t, and the first differentiate of x2 by t is equal to k2 lambda exponential of lambda t. So when we have all terms, then we just plug them back into our linear system. Okay. So the first equation, we would get k1 lambda times exponential of lambda t, which is equal to 5 k1 times exponential of lambda t minus k2 times exponential of lambda t. And our second equation, we would get k2 times lambda times exponential of lambda t, which is equal to 3 k1 times exponential of lambda t plus k2 times exponential of lambda t. If you take a look at these two equations, both of them have lambda and have exponential of lambda t. Every term in our equation 1 and 2 have the term of exponential of lambda t. So we can divide both equation with the exponential of lambda t. Okay. Then we would get, and then let's just arrange the equation, okay, we would get okay. So we are going to move k1 here to the same side, combine with the k1 term, and also this k2 we are going to move to the other side and combine with k2. Okay, so by doing that we would get 5 minus lambda times k1 minus k2 equal to 0, and also 3k1 what plus 1 minus lambda k2 is equal to 0. Now we have two sets of the equation, and then we are going to write out our characteristic equation. Say that the determinants of this term should be equal to 0. That's called characteristic equation, right? So we would say that 5 minus lambda minus 1, 3, 1 minus lambda. The determinant of this one is equal to 0, and this is called characteristic equation. From this equation, we should be able to find our lambda, right? Now, the determinant of 2 by 2 matrix, we just do times go down plus go up minus, right? So we would get 5 minus lambda times 1 minus lambda minus 3 times minus 1, which is equal to plus 3. Now, by this term, we would get 5 minus 6 lambda plus lambda squared plus 3 equals to 0, or lambda squared minus 6 lambda plus 8 equal to 0. Can we find lambda? We should get two values of lambda, right? Lambda what? Minus 2 and minus 4 there. So that means lambda is equal to 2 and 4. 2 and 4 are real number and it is unrepeated. So we got unrepeated root for lambda. So that means we are in the first case, right? So what we are going to do, let me put this equation into number 3 and number 4. We are going to put the lambda into equation 3 and 4. 3 or 4, not 3 and 4. Either equation you would get the same number, okay? The same equation. So it says that I put lambda equal to 2 into equation 3. You can put into equation 4. You would end up with the same meaning, okay? 3 or 4 is the same meaning. But I picked up the equation 3, okay? So when you put lambda equal to 2 into equation 3, you would get what? 5 minus 2 equal to 3. You would get 3k1 minus k2 equal to 0. Or you can say that your k2 equal to 3k1. So it said that assume k1 is equal to 1, then k2 equal to what? 3. It's going to be like this correlation all the time. If k1 equal to 1, k2 equal to 3. If you assume k1 equal to 2, k2 equal to 6, something like that, okay? So, from this, we would get our first set of solutions. This is lambda is equal to t, right? So we got k1, k2. Now, k1 is equal to 1, lambda 1 is equal to 2. Right? So if we write down it in the term of matrix, we would get the second set of our solution. We just put lambda equal to 4 into equation 3 again. Equation 3, our equation 3 said that 5 minus lambda k1 minus k2 equal to 0. Now if you plug lambda equal to 4 there, you would get k1 minus k2 equal to 0, or k1 is equal to k2, right? And from that, because now we know that our second set is that k1 equal to k2, then if we assume k1 is equal to 1, so that means k2 is also equal to 1. Now, the second set of solutions is x1 t equal to k1 exponential of lambda 2t, and then x2 is equal to k2 times exponential of lambda 2t, which is equal to exponential of 4, because our lambda is equal to 4. Or if we write down in the term of that, we would get this form, because k1 and k2 are equal. Now, the general solution is it's just linear relationship between the first set of solution and the second set of solution, right? So then we would get C1 times the first set of solution is 1, 3 times exponential of 2t plus C2 times 1, 1, 4t. That's